This is lesson 3 of chapter 6. Today we're looking at equations of straight lines. So up until this point in this chapter, we've just focused on slope, and now we're going to turn our focus to looking at equations. And we're going to learn 3 types of equations in this chapter, and we're starting with the first one today. So this one you've actually seen before, so this might be a little bit of a review. You've seen it back in the previous chapter when we looked at linear relations, and you saw it back in grade 9 as well. So this one we're looking at today is called the slope-intercept form. I'm going to use yellow for slope today and purple for the intercept. So a lot of people know this equation in this format here. Y equals mx plus b. So y and x are the variables in this equation. They are, when you're looking at a graph, they are the numbers on the vertical and horizontal axes, right? And so those are changing. But m and b are numbers that describe the line. So the m refers to the slope, or sometimes we call it the rate of change. In the previous chapter, we called it rate of change, so I'm going to write that here. And the b is the y-intercept. Some people call this the starting point as well. Okay, so let's look at this graph as an example here. B here is 2 because the y-intercept, we can see the graph hits the y-axis at 2. And the slope, if you count from one point to another, you would count 3 down and 5 to the right. So the rise over run would be negative 3 over 5. So when I write my equation, I write it like this: negative 3 over 5x plus 2. So we're going to practice drawing some graphs given these equations, or making an equation from a graph, and then we're going to do a couple of word problems, all using this format. Okay, first example, we're given some information, we're going to write the equation and then graph the line. So here it says a linear function has a slope of 3 over 5, so it's going to be going up, and it has a y-intercept of negative 4. Okay, it says write an equation for this function and graph it. So we're going to write the equation in the y equals mx plus b format. So here we have 3 over 5 as our slope, and our b is negative 4. Now it's a little bit clunky to write like plus negative 4, so you can just simply write minus 4. It's the same thing. So I'm going to do that here. So I've put in those numbers, and that is my equation. And when you graph, you want to start at the y-intercept. That's why sometimes people call it the starting point. So when we're graphing our line, we're going to start at negative 4, and then I'm just going to count out the slope. So my slope is 3 over 5. So the rise is 3, the run is 5. So I'm going to count 3 up and 5 to the right to get my next point. You can also count backwards if you run out of room. So I'm going to count 3 down and 5 to the left. And then once I've kind of used up all the room on the coordinate grid, you should draw a straight line. You should use a ruler to draw your lines. I just can't use one on this screen, but tried my best there with a straight line, and you can erase any counting lines there because those are not actually part of the graph. There we go. Okay, so there's my line that matches that equation. You can actually verify that you've got the right line. So let me show you how to do that. I'm going to do that over here. So I'm going to verify. I see this point on my graph here. This point has an x-coordinate of negative 5 and a y-coordinate of negative 7. So if I plug negative 5 into the equation, I should get negative 7 as my y value. Let me show you how that works. So I'm going to plug in negative 5 into the equation there. Actually, sorry, I'm going to use pink here. So my equation is 3 over 5x minus 4. So I'm going to plug negative 5 into the x position because that's my x coordinate, and hopefully I'll get negative 7 as the y value, because that means my equation is actually correct and I've graphed it properly. Okay, now when I multiply these two, the 5's actually cancel, so I get negative 3 minus 4, which is negative 7, and I know I've actually done this right because I can see there that my y-coordinate matches the y-coordinate on the graph. So you can use your equation to find points on the line. Okay, let's do example 2. We're writing an equation to describe a graph that's already drawn for us. So we're kind of going the opposite direction as we did in example 1. So I'm going to highlight some things here. We have the same y-intercept. It's -4 here. And the slope you just want to count, and you can use any 2 points. I'm just going to use the 2 points given, so I'm going to count down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. So my slope would be -6 over 4, and you can reduce it if possible. So this one, you can reduce those two numbers, or sorry, divide them both by 2. And then we are going to put those 2 pieces of information into my equation. So my equation is y equals -3 over 2x minus 4. And you could verify, I'm not going to do it here, but you could verify by plugging in a point on the line and checking to see if it's on the graph. So for example, you could pick a point like this one here, -2, -1, and you could plug -2 into your equation and just double check that -1 is the y value. Okay, let's do a word problem. So here it says the student council sponsored a dance. They earn $5 in revenue from each ticket sold, and they have to pay $300 for a DJ for the dance. So right at the beginning, they're out of pocket $300. And then every time they sell a ticket, their profit goes up by $5. So this is kind of going to be my starting point, or the y-intercept for this function, because this is where we start before we sell any tickets. So the b here is actually going to be -$300 because I had to pay $300 for that DJ. I'm down $300 right from the beginning. And then my profit is going to increase by $5 every time we sell a ticket. So my slope is going to be $5 per ticket, or just 5. Okay, so here for part A, it says write an equation for P profit on the sale of T tickets. So if I was just writing this equation with X and Y, we would do Y equals MX plus B, and we have our B, which is -$300, that's where we start, and we have our M, which is $5 per ticket. So I would just write Y equals 5X minus, oops, I don't know where those came from, minus 300, right? But here they say in the question, like oftentimes in a word problem, we're using different letters that better represent the scenario. So here we're going to use different letters. So we'll have P equals 5T minus 300. So it's the exact same equation, we're just using different letters rather than X and Y for our variables. Okay, and again, it's minus 300 because we start out with a profit of -$300 because we had to pay for that DJ, and then we have to work our way out of the hole as we sell tickets. Okay, so part B, now we're going to use our equation. It says, suppose 123 people bought tickets. So T would be 123. What is the profit? Well, let's use our equation. So I'm going to put the ticket price right into that equation there. So where I see T, I'm going to replace it with 123 and just evaluate this. So if I do 5 times 123, I get 615. And 615 minus 300 is 315. So the profit is $315. Oops, 315. Okay, let's do part C. It says suppose the profit now is $350. How many people bought tickets? So this time I'm going to replace the P in the equation with 350 and solve for T. So this time I'll replace P with 350, and I don't know how many tickets were sold, so I'm going to leave the T as a variable, and that's what I'm solving for. So here I have to use some opposite operations and some algebra to solve for the T. So first I'm going to get rid of the 300 here by adding 300 to both sides, and I'll get 650 equals 5t. And then I'm going to divide by 5 and find that 130 equals t. So 130 tickets were sold. I'll just box that answer in. Okay, so that is the end of the lesson.